Yes, greetings wherever you are, and you're welcome to today's class. We are going to be looking at operators in R programming, but I would like to take the opportunity to revise what we did previously with regards to subsetting and extracting data from any kind of data type. And I will go systematically before I will go into the operators in R. So thanks for being around, and let me bring up my full screen. Right. And so because of time, so we are going to be looking at subsetting, and then we just looked at, for you to be able to subset any data, you need to know the kind of data it is, the data type it is. And so I have some data sets which are here. As you can see, I've already created, I'm sure by now, if you have been part of this class, you should know that this is how we create a vector. We use the vector function, or we use the combine function to create a vector. So at this particular line 135, and if you understand R works in lines. So line 135, we are actually creating some kind of numbers, like as you can see here, we are using rnum to be able to create those numbers, and then we are packing it into this vector. If you run it, obviously you are going to have the vector seated over there. So if I run the data, the vector, you can see the vector has been created. There are about 20 entries, or 20 objects, and this is just the mean, and this is the standard deviation. We use that to be able to create that kind of data. So if you want to subset, if you want to like pick any kind of the values that you have here, let me clean this up. If you want to, this is the vector we have created. By now we should all be aware of this. So if you want to subset it, you use this square bracket like we have here, and then we are able to do that. So the square bracket here is a function that indicates an index. An index is simply a position of an argument or of an object which is being assigned to a variable. All these things you see here, they are objects. So if you do like this, so the object, all the values you are seeing here have been packed into this thing called vect. It's actually a vector. So that's a variable you created, and then you packed all that you have created, the values higher, into that. So if you now want to pick any of the values, you just give it a position. For instance, if I say 1, it means I want the value that occupies the first position. If I change it and I say 7, I want the value that occupies the 7th position. This is how we subset, and so it will only pick that value. If I want values which are, let's assume that I want from the first value to the values which occupy the first position to the 5th position. This is what I'll do. I run that, and they're there. If I want the values that occupy sorry, the 16th position all the way to the 20th position, that's what it means. And this one, that is when you are looking for a vector that does not have you are looking for values, or you are looking for objects within the vector which are not sequential. It means that there are jumps. It's not in position 1, 2, 3 in that order. It's not in order. It is found in position 7, position 3, position 11. And when you are able to, if you have that kind of values that you want to extract, you use the vector function again. So you bring your C, open and close bracket like this, and then you select those ones out. It will select those ones out and print them for you. So as you can see here, the same way, if you also have a vector which are made of characters, so here, let me run that, and then you see. So if I print the vector of characters here, I can simply you can see all of them, A, A, G, T, and then whatsoever. They are all here. So if I want to print the first one, which is AA, I'll indicate, let's say 1. I need to print or just that. So this is how we are able to subset a vector. You can use the combine sign or the combine function to select, the objects which are not in sequential order. You see, and that's what I just explained. So now, after you've done the subsetting, maybe I will talk about these operators later. So I'm going to jump that. And so this is how the subsetting is also done. So we have a subsetting of lists. So I've actually spoken about this in my previous class. So, but if you have a list, so we just created a list here. We have the list function, which is there, list A. And then, so what is going to happen is that this one form one index, the vector form another index, and this forms one index, and then one index. In a list form, anything that you created that is separated by a comma is identified as one position. So if I want to print 1 to 3, I will just indicate 1. So it will print 1 to 3. So if I run this, it's going to just print 1 to 3. But if I want to print what is found in the vector occupies the second position. That is in the case of a list. And that's why in data science, it's good to know the kind of data you are dealing with. Now, let me show this quickly. If I have, let's say I have a list which I have created, and I give it the name list A. So if I come here and I say class, and then I put inside there list A, if I run it, it will tell me the kind of data it is. It will say that it is a list, as you can see here. Now, if I say class, and then I put there the one that I was having vect like this, if I run it, it will tell you that it is a numeric vector. It's numeric, so it's a vector, or what does it tell you in essence? So mostly, if you are looking for the kind of data it is, you can use class to be able to find out which class of data it is, and that is it. Sometimes people use type. You see, type of, and then you put the thing there, then it will tell you what it is. Maybe type of, then let me put vect there, and let's see. So it will say it's a double. You see, so there are instances it will tell you it's an integer. So we use those things to be able to find out the kind of data that is contained there. So if I had used type of in terms of lists, we might get different answers, and then that is it. So now when we go, there are also other ways through which we can do subsetting. This is how to subset a list. Not much is supposed to be said about that one. When we go to subsetting the data frame, we have learned how to be able to create a data frame. So let me go straight to that part. Yeah, so let me simply say that we know how to create a data frame. And so let's assume that I want to create a data frame, which is, let's say, so I can create something like vectors. So I'm going to start, I'm going to move from here going downward so that you understand. So I'm going to create a data frame. So I created my vector 1 to 15. I created a second vector here. So I'm just going to run that, run the second vector. And then this is also a vector, which I am creating using this function called latest. So I have also created that particular vector. And so now I want to create a data frame out of the 3 vectors. So you use the data frame function, but you give the data frame a name. That's the variable name. So I just say the data, I just give it a name like data frame 1. And so to be able to create that particular data frame, you use the data frame function, data.frame. And then you now put the vector you have already created in this small place, depending on which of the vector you want it to form the first column. So here I want the latest to form the first column. That's why I brought this out there. So if I finish and I do this, my data frame is ready. If I do this, if I run it again, you notice that the data frame is here, A, B, C, D, all the way up to O, then in that order. Now I can go ahead If I also want to look at the data frame here on this particular panel, then we use view. But if you don't want to, if you want to look at it in the console, you just run it. You just run the variable name or the data frame name, which is data frame 1. So in this case, if I want to look at it in this particular panel, the same panel in which I am, I'll just run it from there. And so it will print the data frame here on the same pan. And then as you can see. So let's assume that these are names of people, and maybe this is their weight, and then this is their height or something like that. So we can just look at it, and this is how we are able to create a data frame. So here, this is the first column. Remember, this was a vector. But now that the vectors are arranged in longitudinal manner, in this arrangement, it is called a data frame because there are columns and then there are rows. And so that is what I was talking about. Now, if we have it this way, these rows here, row 1, row 2, all the way up to this, and column 1, column this. So the columns are usually, the column header is a variable, that's the D3, that's the variable name. The variable name is called D3. So D2 is here, and then D1 is also there. So they are variables. Now what we have here are the objects or the entries or the data points. You see, they are the objects that I am talking about. So the entries. So if I go back here, and I want to do any kind of subsetting, it becomes simple. For instance, I've already spoken about subsetting a vector. So we've looked at, let's say, if I pick one of the vectors, which is D1, remember, we always create vectors first, and then we can use that to create a data frame. Even though you can create a data frame straight away, like in the case of data frame 2 that I have here. So in that case, data frame 2, I just use the data frame function. Then you come and say D4 is equals to 20 is to this, D5 is equals to 30 is to this, D6 is equals to, that's another way of creating data frame. And when you run that and then you print it, you are also going to have the same data frame, that kind of data frame also here. And that is it. It's not, so there are various ways through which you can create a data frame. You can also create it using functions, inbuilt functions. What is it? When we start doing functions, I will talk about it. Now, the other thing for now is how do we subset? I've already spoken about how to subset a vector. So a vector, like here, I want to print just the value which occupies the 7th position. And then this is also a vector. I want to print the 7th to the 12th position, the numbers which occupy the 7th to the 12th position, but I want to pack them into a variable. So if I run it like that, then it will be packed, the results will be packed to the variable. In essence, we have extracted the data like that. So if I can now work with that particular data. You see, I can visualize that data here, as you can see it, the same thing here. If I want to do any kind of mathematical operation, I can do it. So I have extracted the data, or I have subset the data, and then I can now work with that data alone. So let's assume that it was a data that was so large, but we didn't want everything. So we just decided to extract the portion that we needed. And so let's look at something here. These are students. We just created a vector here. Let's say we were looking for students of KNUST, and we are looking at the students using their indexes from first to 2,000 students. So if you do that and you run it, you notice that if I pull it out, then you can see, maybe I should say that student, I should have students underscore NUST, which is here. And then if I run it, you can see, look at all of them, and then their positions. So it's going to start from 1 all the way up to 2,000 students. So now, if I come here, let's assume that we want to extract, and let's say this 2,000 students occupy College of Science. All right, College of Science has several faculties. Let's say Faculty of Biosciences, and then Faculty of Physical Sciences. Let's focus on Faculty of Physical Sciences, Biosciences. Now, all these students are in Faculty of Biosciences, 1 to 2,000. And now we want to subset. We want to extract part of the students and then be able to work with them. So what we are saying in essence is that I have, I'll go and then let's assume that the first student or the first index number to the 100th index number, they are all in Department of Biochemistry. So what do? I will say I'll create a variable called biochemistry and come here, bring that variable that contains the index numbers, which is students underscore nust. Then bring your square bracket and say 1:100. It will extract only 1:100 into that. And so now, if we want to find out, if we want to pick only the student from biochemistry, we can run just biochemistry alone. And you see that there are only 100. That's the first 100. So I could have come here and say, I want all the students in biochem. So that one is not there. Now let's also think that the students, the second department, that's nutrition. Their students also occupy the positions of index number 101 all the way to index number 200. So if I do that, if I run it, then I've also extracted those students. So I will also come here and say nutrition, and then in that order. So if I run nutrition, you will also see that those students are also out. I've extracted that and packed it into a variable called nutrition. I can do the same thing for optometry. So when we go to optometry, we notice that the students' index numbers are not following. They are not in sequential order. Some of them, they occupy the positions, or some of them, if you check in the list of the students, from student index number 201 to index number 260, they all belong to biochemistry. But from 261 all the way to 271, they are not part of biochemistry. 270, they are not part of biochemistry. So we cannot just subset them like the way we did the first one. So what we can do here is to use the combine function, like I've already mentioned, to be able to isolate those students whose index numbers are not following in sequential order, but belong to the same department. And this is the technique we use. So we come here and we'll notice that from 201 to 260, they all belong to optometry. But from 261 to 270, they are not in optometry. So we skip that, comma, and then we come and continue. 271 to 290, they also belong to optometry. And then the student who occupies the 300 position, that particular student, also belong to optometry. So when we do this, how we are able to isolate data points which are not in sequential order using the index positions. And then when we do that, we run it and we can see that we have our optometry just in there. So these are also students from optometry. And so that is how we are able to subset data which is in the list form, or which is in the form of a vector. So this it has been arranged. So you just need to know how the arrangement is being done, and then you can apply your functions, and then your function will simply isolate them out. So what would have meant is that you should have already a vector that contains the index numbers. You only need to put the vector inside here and then to isolate it out. So this one I'm just saying that now that you have isolated the data that you want, you can now perform whatever that you are looking for. And that's what we call data science. It's about your ability to extract any information that you want from any data. So if you know how to extract any information you want from any data, you are a data scientist. And so here we have extracted all the students from optometry. So we can begin to we can do a scatter smooth plot and see how that's going to look like. You can zoom that out, and so you can see how it's going to look like. And so maybe that's all that we wanted. and then that is all. Now, that's for vector. Yeah, we can also subset a data frame. Now, in subsetting a data frame, we've already created a data frame 1 and data frame 2. Now, we use three methods in subsetting the data frame. We can use a $sign. In this case, you write the name of the data frame, the $sign, and then plus the name of the column. In fact, if I remove this, if I put dollar here, you can see something like D4, like this, and then the $sign will already suggest the variable names or the column names. And in that case, if I click on this, it will simply select that particular column alone. That's column 4. And then that is it. So we have taken that out. If we wanted that particular data alone to be able to work with it, if you're a beginner, then you can simply pack it into a new variable. For instance, I could just put it this way and do like this. This one is called write assignment. And so I will simply just do that and go and call it and say I am putting it in this variable. And so maybe I can call this variable 1. If I do that, the results will now be packed into variable 1, and then I can begin to work with variable 1. For instance, if I come back here, I can now say, let's say I want a histogram of variable 1, var1 here. If I do that, you can see that the histogram has been. So look at how it's going to look like. And then that is how we are able to, extract data and be able to work with it. So all that we're looking for is just that particular column. So we pick that out, and then we do whatever we want to do with it. You can now there are other ways. That's for the using the $sign. There are other ways of using the $sign. For instance, if I come here, if I have the df underscore 2 like this, and then I bring the $sign. So the $sign will simply suggest this. I've picked only one column, but maybe I'm not interested in everything in that column. I can still bring something like this. You see, I can still bring this square bracket, and then in that case, within that particular column, I am looking for the values which occupy the first position to, let's say, the 8th position. And when you do that, so this one is subsetting and also subsetting. All right. So we have subsetted the column, and then we've gone to subset what is also contained in the column. And this is how we are able to do it. So you select the column first, then you go and select within the column. And it's very simple like that. If I want to pack the result somewhere, then I can use my write assignment, like what is this, like this, and I can go and call that one variable 2. And then that is also there. So these are the various ways through which we can subset. If you don't also want that, you could have also come again to come and use this. Use the square bracket by the data frame. And when you do that, you bring a comma. This comma here separates rows and then columns. To the left of the comma is the rows. The right is the columns. Now, if I put 1 here, just like you are seeing, that one means that we are selecting only the first column. If we wanted to, so if I do that, it's going to print the first column, just like the way we did the dollar to print the first column, as you can see them down here. So that's how we are able to. Now, if I come here and I put 1 like this, it means I am selecting only the first row of all the columns. In arrow, let me indicate this. If this comma here is separating, is separating the rows and the columns. If I don't put anything in the rows parts, it means all the rows. If I don't put anything there, it means all. You cannot put 0 there. You don't have to put it all, and that's how it is. If I come here, if I don't put anything on the column side, it means I am talking about all the columns. First row of all the columns, and that's what it means. The second one I have here, I was saying that I want the value of the first row and then in the third column. So it's just one value. It's going to be one value. And so when I do that, print only one value, that's 60. It's actually an intersection between the row 1 and then column 1, where row 1 and column 1 intersect. That is where we pick the value from, and that is it. If you also want them in series, from here, line 219, we are looking at the values which fall from 1 to 5, from row 1 to row 5, of column 2 to column 3, and that is it. We select those out, and then we are able to do that. The same way, we could have come here, but in this case, we are selecting rows and rows which are not in sequential order. So we still use the combine function, but always remember, when you are creating the data, is always you bring the name of the data frame, like gf data frame underscore 2, and then when you bring your square bracket like this, always put your comma first before you begin to do whatever you want to do in the row sector and then the column sector. So if you know I am picking some rows which are not in sequential order, then I'll bring C. I will simply say, I'll type my C like this, go and my shift and 9 to open and close this small bracket. It means we are still working in the rows sector. So in the row sector, we are looking for row 2, let's say, comma, we are looking for row 4, comma, and maybe we are looking for row 7. Then we finish. Now we now come to the other side of the comma, and then say that we are also looking for this in how many columns, and then we can also select the columns. If the columns are not also in sequential order, then we also use the combine function to be able to do that. But if you leave it like the way I've left it, it means that you are selecting these 3 rows which are not in sequential order in all the columns. And so if you run that, it's going to print that for you. And then the same way here, that's what we just applied here. And then we pack that one into this variable called variable 4. And so if you run that, our variable 4 will be here, and then we can print variable 4 to look at how it looks like. And that is it. The variable 4 I created there, that's left assignment. And so I could have come here and say my variable 4, which is there. When you run it, you're going to have it. So now it's the same way I also have it here, like I have done here. Now we have this called, let's say I'm trying to explain the College of Science scenario quite better right now. So, but before that, let me say that we have whatever I have here, I have done in, let's say, the rows and the columns, whatever I have done with the data frame, the same thing can be applied in data matrix. So I'm going to jump data matrix. We've already learned how to create data matrix, and then so you can simply try all of this that I have done here. Everything will work perfectly in data matrix or in matrix data. It's the same in the same format. So because of that, I'm moving all the way to arrays. How do we subset arrays? So I'm going to create an array of 100 students. So, and now, when we are creating an array, we have the data points here. We have, let's say, the number of rows. So we use the C function. We have number of rows here. We have number of columns. And how many arrays are we looking for? In this case, we are looking for 5 arrays. So if you run that, the array is ready. If I print this out, you're going to see that we're going to have different arrays. This is array 5, and then this is array 4. As you can see, 4 is written here. Sorry. As you can see, 4 written here. This is array 3, and then as you can see, 3 on top. Then we can also have array 2, and we can have array 1. We could have given the array some names. We could have given the arrays some kind of names, and then that will allow us to be, but I'm going to be doing that subsequently. Now, if I have this, and I am assuming that that's College of Science, and I'm looking at the staff strength there, and then we want to be extracting some stuff. Now, when you print an array data is basically so useful when you are dealing with different departments, and then the department also have different units or different faculties. You are dealing with like big companies where they have different segments. So if we assume that this was College of Science, we can say that array 1 forms, let's say, okay, let me say that was Faculty of Biosciences. So we can say that array 1 may form the Department of Biochemistry. Under the Department of Biochemistry, then we can come here and come and look at, okay, no, let me put it at College of Science level. So if I put it at College of Science level, the whole of this will be, let's say, Faculty of Biosciences. Under Faculty of Biosciences, each column will represent a department. So this is Department of Biochemistry, Department of Nutrition, Department of Optometry, maybe, and then other departments which are found within that. And then that is how it is. Then when we move again, we have Faculty of Physical Sciences. So where we have Department of Mathematics, we have Department of Statistics, we have Department of Actuarial Science, we have Department of Computer Science, and then in that order. Then we can move ahead and say, let's say we have Faculty of Pharmacy. So we have Department of Pharmacology, we have Department of Pharmacognosis, we have Department of, let's say, Herbal Medicine, we have Department of Veterinary Medicine, and then in that order. Then we can come here and then look at this another faculty. So this is how that kind of data, we deal with array data. It allows you to be able to put all sorts of things. So now let's assume that I have all this that form College of Science, and the College of Science data is cited here. In this case, my interest is in Faculty of Biosciences. Faculty of Biosciences is array 1. You see, I could have named them. So I'll simply come and I use the square bracket like this. If you have College of Science like this, so you always bring your square bracket this way. I have 2 commas, 1 and 2. So the first comma is separating the rows. The rows are the actual data points. Here are the columns. Here are the specific array. In this case, let's say if I want the number of rows, if I'm looking for 5 values or 5 rows, 2 columns, in which array am I looking for it? Then you select the array. Okay, and that's what we always use to be able to deal with array data or to subset array data. So I'm going to do this. This was there already. So we use this function to be able to do that. So when I come here, if I write this one, it means I am selecting just one array, that's array 1. If it were in real life situation, we are looking for, let's say, Faculty of Biosciences, which occupies array 1, and that's all. When you do that, it prints only that particular one. So it will print only that one, as you can see. It will print only that particular faculty. Every information about that faculty will be printed. And that's how it is. The data science is much more of like you being a little bit, creative. It's an art, so we have to be creative. All right, so if I come here, I am looking for Faculty of Biosciences, or let's say I'm looking for array 1. But when I go to array 1, I'm not looking for everything in array 1. I'm looking for column 3. And then in column 3, I'm looking for all the rows in column 3 in array 1. So when I do that, it's going to print it in a vector format. As you can see it down here. That's how it looks like. If I come to this, I am going to look for a data set in array 1, and then I'm looking for column 3. But in column 3, I'm not looking for all the data points, or I'm not looking for all the rows. I'm looking for from row 1 all the way to row 3. So I'm going to print just 3 values or 3 objects, and that is it, as you can see it here. So this is how we are able to select the data just like the way we want. But for you to see it in real practical sense, I will say that, okay, here I'm looking for some stuff in Faculty of Biosciences in College of Science. So I have a whole data set of College of Science. So I'll bring that data set out. Then go and select which Faculty of Biosciences, which is represented by 1, is number 1. If I go there, which department am I looking for? Maybe I am looking for, column 3 represents Department of Nutrition. So I'll go and put there 3. But in that, I am looking for the lecturers or the data points 1 to 3, which might be the lecturers whose IDs are from 1 to 3. So I'll just select only those lecturers, and that's all. And so the same way I come here, I'm looking for array 1 in column 1. In this case, let's say I'm looking for the Faculty of Biosciences. I'm looking for Department of Biochemistry, which is represented by the first column. And then I'm looking for the lecturers, the first to the 10th lecturer, their IDs. So I simply just do that and print the 10 of them, and that will print them out here. This is how we translate real data science or the conjecturing data science that we all have into real life situation. Okay, the same way I have here. Here I'm looking at array 5. Maybe array 5 maybe Faculty of or that may be KMUSC Medical School. And then we go there, and then we are looking for the department who occupy the 3rd column. So we put 3. And then we are looking for just 3 rows, just 3 rows. So we are looking for the 3rd row, and then we are looking for it. Who is this lecturer who occupies the 3rd row in the 3rd department in array 5? So 1 person. So that particular lecturer, the ID is 43, and that's how it is. It's quite simple. Here we are looking for the rows from row 1 or to row 5 in all the columns in array 5. So it will print that for us, and then as you can see. So this is how you can also use the combine function to be able to make sure that you also separate maybe the specific rules that you are looking for in the specific department and then in the specific array. And then when you do that, you can also subset it, and then which is here. You can do this in several ways. And that's how we are able to subset vectors, lists, data frame, matrix, and then data arrays. Now let's look at operators in R. Operators, there's a difference between operators and then functions. In R, operators are in 4 categories. We have arithmetic operators, which is the addition, subtraction, multiplication, division, modulus, floor division, and then exponential power. Now, when we go to the other parts, we also have logical operators. So the logical operator, it retains a boolean, whether you want to find out whether something is true or not. Then we also have something we call relational operators. And then the relational operators, you want to relate whether you want to find out whether one variable is related to the other variable, and that is it. And then the last one is assignment operator, which we have been doing all this while. The assignment operator, it depends on how you want to assign your variables. And then, so let's go ahead and start. So here I am just adding 2 plus 2, and here I am adding from, this is what I'm talking about, and then I am there. So let's look at, I am adding the 1, 2, 3 to 5, 6, 7. So you do that, and it's going to add them accordingly. Here we can create a vector. So we've created a vector 1. We are creating vector 2, and then we can add the 2 vectors. Let me remind us, to add 2 vectors, they must have equal length. If you have a vector of entry of, let's say, 10, the other vector of entry of 9, when you are adding it, you're going to have a problem. Even if it's add, it's going to give you warning. Yeah, so that works just well. And so you see that you won't have any kind of issue. Now, we can also add, we can also add a specific value within the vector to another vector. In this case, we are looking at vector 1, but we are looking at, I'm talking about line 259. So in vector 1, we are looking for the value which occupies the 3rd position. I want to add that value to all of vector 2. So that value will be added to every single value in vector 2. Now let me print vector 2 first, and then you look at something. Vector 2, let me print it out. As you can see, vector 2 down here, from 12, 13, all the way to 26. Now, let me now run the full line and you see what is going to happen. So you notice that 3 has been added to this to give us 15. 3 has been added to give us 16, has been added to give us 17. So the 3 will be added. It means the value which occupies the third position in vector 1 is 3. And that's how it is. So that 3 will be added to all of them. So when we come here, we are going to pick the value should occupy position 2, position 3 to position 4, and add it to vector 2. So it's going to add it in succession. For instance, let me brush this off and then do this again. So I have my vector 2 here, which is running, which is down here. Now, if I want to add, I'm going to vector 1 and I am picking up just the values which occupy the second position, the third position, and the fourth position. And in this case, coincidentally, there are also 2, 3, 4 because of the way I simulated the data. So, but you should know that this one are representing the positions, not that it is going to pick 2, 3, 4. No, it's going to pick a value in position 2. That if that value is 8, it will pick 8, not 2. So let's take note of that. And so it will pick those values in position 2, 3, 4, and then add them in succession to this. In succession here, let me run it and explain it better. So you notice that the values which occupy position 2 to 3 to 4 in vector 1, those values are 2, 3, 4. So now when we come, 2 will be added to 12, 3 will be added to 13, 4 will be added to this, and that's why you have 14, 16, and 18. Again, the same thing, 2 will be added to 15, 3 will be added to 16, 4 will be added to 17, and that's why you have 17, 19, and 21. It will add like that in succession until it's finished. And that's how we are able to do it. So these are things we call their operators. But know that apart from the operator, you can combine the operators and the subsetting and the subset. So you can simply isolate the data you want before you apply your mathematical operation on it, and it will work just fine. Here, if we do this, it means we are negating every value in that particular vector. So every value now becomes negative. If we do that, and here, what I have done here is I have just reversed. I have reversed the vector. There's something we call inversing a vector and then reversing a vector. So inversing simply means negate the vector, but reversing the vector means if the vector was counting 1, 2, 3 up to 6, you are now counting 6 all the way to 1. And here the vector is 1 to 15. So because we want to reverse the vector, we now give it an index 15 all the way to 1. And then that just works well. And so before we come to do this, and so here we are reversing the vector, and then we are adding it to inverse of this particular vector. And because we are adding and then the vector is already an inverse, it will simply mean that we are subtracting vector 2 from this. And that's how it is. So we run that and you can see the result, which is here. Okay. So you can, if you know how to be able to apply addition operators, you can also apply the same subtraction, multiplication, and division. Each of them will work. And so when we come here, we are looking at division. The same syntax, it will work. And then as you can see, it will divide the vector in succession. So we are dividing, we are looking at the values, we are looking at 2, 3, and 4. In this case, we are not looking at positions because there's no vector that it is attached to. See, here we are just looking at the specific values 2, 3, and 4, and we are multiplying it to this particular vector. Remember, there's no square bracket here, so it's not an index, it's the real values. Yeah. So here it will multiply them in succession. Here, divide them in succession. Now, how do we apply these operators in the data frame subset? So now we have subsetted this particular one, that's data frame 2, and we isolated the column which is called D4, and we multiply it by 2. So 2 is going to multiply every value in column D4, and that's it. So if you run that, it's going to multiply it for you. The same way here, we could have used the square bracket, and here we are looking at column 1 and then column 2, and then we are multiplying each column, each value in that particular column by 3. And so what I'm going to do is, of all the rows, yeah, I've already mentioned this. Once you don't see anything in the rows parts, then it means that you are taking all the rows. And so you see that it will upgrade all of them to, it will multiply all of them, just like you are seeing. So we could have also divide, all the columns there by 3. And so here it will also work just well. The same thing we have here, you simply select, or you do all the subsetting that you want, which I've spoken extensively, and then you apply any mathematical operator just like you have it here, and then that will just work fine. Over here, we are dividing 5 divided by 3. When we divide it in normal sense, what do we get? We get 1.6. But when you, in R, when you see percentage, we call it modulus. It's just like when we're doing number base in basic school. So we are looking for the remainder. So if I run this, you are going to see 2. So it means that when you divide 5 by 3, the remainder will be 2. So it rather gives you the remainder, all right? And then there is a way. The reason why we have this kind of syntax in R is that it allows us to be able to know, to choose which one is a prime number, which one is an odd number, which one is an even number, and then in that order. If I divide anything by 4, and then that thing is equal, the remainder is 0, it means, what is it? I know what that means. Let's say I have 2023. If I divide 2023 using modulus by 4, and then the result is 0, it means that 2023 is not a leap year. If the result is not equal to 0, it means 2023 is a leap year. For instance, if I say, if I do like this, 2023, and I say modulus 4, leap year comes every 4 years. So you divide it by 4. So once you have the remainder, which is 3, it means that 2023 is no, is it not? Yeah, it's not a leap year. I think so. Yeah, it's not a leap year. So that's how we are able to use them. Now here we are talking about floor division. This one is called floor division. Let me put on top here, we're talking about modulus. Here we're talking about division. So I would have just put here division. And then if I come here, I was talking about hashtag, we're talking about modulus. And then over here, what we are talking about